All right, so I'm looking at this Blase Bleed right here. That is page 5. And so I'm trying to find shortcuts to determine which graph matches to what equation. So let's look at what we got. So for the most part, you're not going to have to deal with stuff like these, but we're going to talk about them anyway. So I got y equals 4 sine 4x, or sine of 4x. Well, if I think about this thing, I've got a times sine or cosine of b times x minus c plus d. So d is my vertical shift, c is my phase shift, b is my frequency, and a is my amplitude. Amplitude tells me the height from the midline to the highest point. So I need to look for graphs that have a high point from the midline to 4. Well, let's look at this. A goes 2, what's that? That's 4. Right here, B goes 2, and then what's that? 4. What's important to realize is those are the midlines of those. So here's another one that goes to 4. See, from the midline to 4. See, do we got any more to go to 4? No. So A, B, and C are my 3. Well, then let's look at how many C's or how many 4s we got. Say brown. So I got this one right here. I got this one right here and this one right here. So next we're going to look at the frequency. So the frequency here is 4, right? My number times x. So that's 4. So what does the frequency of 4 mean? Well, remember what frequency does. Frequency says how many graphs can you fit between 0 and 2 pi. So fitting 4 graphs between 0 and 2 pi, that means I'm going to have a bunch of squished up lines. Because usually when I'm looking at sine, I'm going to have 5 points here, 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 and here. Looking at cosine, I'm going to have up here, here, down here, here, and there. So if that's the case, if the frequency was 1, it would just be 2 pi there. But if my frequency is 4, that means I've got 4 graphs that fit within. So that's 1, 2, 3, 4. So let's look at those 3 graphs that we got and see which one fits within 2, 4. Well, let's look right here. This goes from 0 to up, and it hits there at pi over 4. It's down here and hits right here. So if this is pi over 4, this is pi over 2. Because pi over 4 and another pi over 4 is pi over 2. And if that's pi over 2, this right here, that will be 3 pi over 4. So there's 1. There's 2. All right, 1, 2. I still got 2 more before I get to 2 pi. So see, A and C, they're very similar. Well, let's look and see what we got. Well, I've got 4 sine of 4x. I've got 4 cosine of 4x. And then I got this odd man out, 4 sine of 1 over 4. So because these are similar, that's telling me that I need to think about these two. So then the last thing is, what did we just say that the graph of sine looks like. It starts at the midline, hits the high point, goes back to the midline, hits the low point, goes back to the midline. Right here, starts at the midline, hits the high point, goes back to the midline, hits the low point, midline. So A will be sine. That would be A. And so then that means cosine, start at the high point, hit the midline, go to the low point, back to the midline, high point. So that'd be C. And then the last one is 4. Let's look at it. So it starts at 0, hits the high point, midline, low point, high point. So what's this saying? Well, that says 2 pi. And then that means that this is 4 pi, that this is 6 pi, and this is 8 pi. Well, so one complete cycle, it took 8 pi. So if I have 2 pi over my b, that's my period. That's how long it takes to complete one cycle. So 2 pi over 1/4, if that's my frequency. That's a keep change flip problem. 2 pi times, or divided by 1/4. That's 2 pi times 4/1. 2 pi times 4 is 8 pi. So I'm gonna clear up. So look, this right here, just this part of the graph, is 0 to 2 pi. And how much of my cycle do I got? Well, there's 1/4, there's 2/4, there's 3/4, there's 4/4. There is 4 pieces there, or 1/4. So this is not that, this is B. So next, it's a little self-explanatory. If I look at E and G, the midline is different than all the rest of them. The midline on all the other graphs is the x-axis, except for these two. Well, there's only two that have vertical shifts. There's this one, and this one, vertical shifts. So there's one that goes down, which is this one, because it's a minus, and then one that goes up, because it's a plus. Now, I don't even have to investigate the frequency. All I'm doing is thinking about what goes down and up. This one, there's the midline, and when I look at my graph, the graph went down. So that means G has to be this one. And this one, my midline, would have been here, but my midline gets moved up right here. So my midline went up. So that means that's this one. So that's E. So now these two. So I have sine, I got cosine. So let's think about what do we got? So this one right here. Okay, so we started the midline. We go low, come up, and then end right here. So cosine of pi. Well, look, there is no pi here. So if I moved pi, or whatever, I would have a pi there for my movement, and cosine would have started right here. That's not pi. Well, let's look at this real quick. There's pi, and see that? My cosine would have started up here, move pi. So that tells me that this is D, and then whatever's left, that's F. So I could look at it this way. Sine starts here. Well, if sine starts there, and that right there, if this is pi over 4, that means this is pi over 2, because pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. So that's one move. Now technically, my move is back here, but you get it gives you the same result, because all we're trying to do is just kind of guesstimate which matches. So there's my pi over 2 move, there's my pi over 2 move, boom, I'm done. So that's how we kind of get around, and we just kind of finagle looking at the pieces that we got and the graphs that we got. So now we're going to do this one. So this is sine of theta and cosine of theta. So we can use our handy dandy chart on a couple of these, and then we're going to have to make a change. All right. So what is sine of 150? Sine of 150. Sine is the second value, is 1/2. So what about sine of 4 pi over 3? 4 pi over 3, that's sine of 240. That's negative square root of 3 over 2. And well, 675, well, that's bigger than my unit circle because my unit circle only covers 360 degrees. So if I cover more than 360 degrees, what I do is I take away one complete cycle or revolution. So that's 5, that's 1, and that's 3. So remember what we said before when we were doing that one problem. One revolution, that's 360. And so if we take that away and then we see how much is left goes to 315. So now we just look at 315. 315, what was it, sine or cosine? I think it was sine. Sine of 315. Sine of 315 is negative square root of 2 over 2. I'm going to do the same for cosine. 7 pi over 6. 7 pi over 6 is right there. 210. That's negative square root of 3 over 2. Say square root of 3, right? Negative square root of 3 over 2. All right, next. Uh-oh, that's more than 360 degrees. So let's take 360 degrees away, and we got 120. So 120 is negative 1/2. And finally 2 pi. 2 pi is exactly 360 degrees, so I go right all the way around. And then what's my cosine? 1. And that's page 5. Let's see, do we want to do page 6? Yeah, okay. Now remember what we're dealing with here. Okay, SOHCAHTOA. Which is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then the other three are just reciprocals of that. So if I'm looking at sine, the reciprocal of sine is cosecant. So that's hypotenuse over opposite. And then the reciprocal of cosine is secant, which is hypotenuse over adjacent. And then I'm looking at tangent of B. So I didn't put the cotangent on there. It's okay. So now let's just get it going. Opposite over hypotenuse. Well, hypotenuse is 13. And if we're looking from A, opposite is 5. So that's 5 over 13. And then cosine of A. Cosine is adjacent over hypotenuse. It's 12 over 13. And then tangent of A is opposite over adjacent. That's 5 over 12. So now cosecant, that's the opposite. So that's hypotenuse over opposite. So that's 13 over 5. And then secant is the opposite of cosine. So that's 13 over 12. And then finally, cosine of, or tangent of B. So now we're taking this as my reference angle. That's opposite over adjacent. There we go. Easy peasy lemon squeezy, right? And now we're talking we're talking probability. So I got a spinner. It's got 1, 2, 3, 4, 5, 6, 7, 8 spots. Let's not do that. So the thing to remember that there's 8 possible outcomes. So what is the possibility or probability of the spinner landing on a C? Well, how many C's do we got? 1. So that's 1 out of 8, or 1 out of 8. I wouldn't trip if you wrote it like this, but you got to remember that if you're in a spot where you need to reduce, you still have to reduce. So that's why it's better to write it as a fraction or ratio. What is the probability of not spinning on a C? Well, there's 1 C, so not spinning a C is all of those. That's 1, 2, 3, 4, 5, 6, 7. So that's 7 out of 8. Okay, what is the probability of landing, or the spinner landing on A or B? Well, there's 1, 2 A's and 1 B. So that's 1, 2, 3. So that's 3 out of 8. So far, nothing had to be reduced. And this is either or. What is the probability of the spinner landing on one of the first 5 letters of the alphabet? Well, first 5 letters of the alphabet, A, B, C, D, E. So there's 2 A's, a B, a C, 1, 2, 3. So that looks like 1, 2, 3, 4, 5, 6, 7. That's 7 out of 8. Again, so far I haven't had to reduce anything. But you always need to watch. Are you more likely to spin a vowel or a consonant? First off, you need to know the difference between a vowel and a consonant. So how many vowels are there? 1, 2, 3, 4, 5. There's 5 vowels. And consonants, there's 1, 2, 3. So which more likely? A vowel. And explain why. I'm not gonna make a big deal out of it, but more vowels than consonants. And that's that. Let's see, what's the last thing we got? Ooh, fun times. Okay, we'll just knock this out, and so then that'll be the end of this. So this one represents a special triangle that's a 45, 45, 90 triangle. So that's 45. If that's 45, it's understood that that's 45 because all 3 of my angles add up to 180. 90 plus 45 plus 45. That's 90 plus 90, that's 180. If I have a triangle that's like this, right? The pattern is, if I call this, let's call it F for 45. This is F, and this is F times the square root of 2. And then if I look at this triangle, that is a 30, 60, 90 triangle. So if I start with that side that's opposite 30-degree angle, we're going to call that T for 30, I guess. And so then the hypotenuse is 2 times T. And then the side that's opposite the 60-degree angle, that is T times the square root of 3. So how is that relevant to what we're doing? Well, let's look at what they gave us. They gave us this is 45 times the square root of 2 equals 45. Or sorry, not 45, 14. See, there's my 14. It's right here. F of the square root of 2. So I just solved this equation to get my F. Well, I'm going to divide by the square root of 2. So these go away. They divide each other out. I'm left with F equals 14 over the square root of 2. Well, we know we can't leave it something like that. We need to rationalize. So I'm going to take 14 over 2 and multiply it times the square root of 2 on the top and the bottom. So 14 times the square root of 2 is just 14 square root of 2. Square root of 2 times the square root of 2, because they're both under the radical. Remember when we were talking about being in the room and out of the room? So if they're both under the radical, they can interact. So that's 2 times 2, that's 4. And I also know that the square root of 4 is 2. So I have 14 over the square root of 2 over 2. I can reduce that. That's going to be 7 square root of 2. 14 divided by 2 is 7. So now I know that my F is 7 square root of 2. And what do I know? Both of those equal. So that's 7 square root of 2. So now I'm going to do the same thing over here. So this right there is the side opposite 60. So side opposite 60 is t times the square root of 3. And that's going to equal 18. So I'm going to do the same thing. I want to get to t. So I'm going to divide by the square root of 3. That gives me t equals, because those cancel each other out, and that's going to give me 18 over the square root of 3. Well, I can't leave it like that. So it's 18 over the square root of 3. I'm going to multiply by the square root of 3 on top and bottom. And that's going to give me 18 times the square root of 3 over square root of 3 times the square root of 3. They're both in the room. So that's 3 times 3, that's 9. And I know the square root of 9 is 3. And that's 18 square root of 3. 18 divided by 3, I can do that. That's 6 times the square root of 3. So I go back up here and say t. See, t is the side that's opposite the 30. So y is going to equal 6 square root of 3. So that's what I got for, yep. Okay, so now I know that this one right here is 2 times t. So I just take 2 times 6 times the square root of 3. So that's 12 square root of 3. And then we are done with that puppy. All right, if you watched all these videos, I'm going to tell you, so you'll know, that I think I cut a couple of problems out, and I shrunk some problems where there might have been 3, I only put 2, or where there might have been 2, I put 1. So here you go. That's all of it.